So the compound interest formula is the future value, this is for both, future value equals the present value times 1 plus the rate divided by the number of compounds raised to the number of compounds times time. And basically what that's doing is breaking the interest up into individual payments and then multiplying by that many payments. So if I started with $50 and I was increasing at 3% for 6 years, and then I'm doing annually, then that would be 50 times 1 plus 0.03 over 1 raised to the 1 times 6 is 6, which basically comes down to 50 times 1.03 to the 6th. Right? That's our old formula. Right? And whatever that is, 50 times 1.03 raised to the 6th, we will end up with $59.70. But if we compound semi-annually, which means twice a year, then we will get a little bit more money. And basically what happens is, halfway through the year, you get 1.5%. And then at the end of the year, you get 1.5% for that half of the year. So the formula would be 50 times 1 plus 0.03 over 2 raised to the 12th. And the way this is working is, instead of 3% once a year for 6 years, we are going to get 1.5% 12 times, which is every 6 months. Does that make sense? That's what the formula is doing. Instead of 3% 6 times, we are going to get 1.5% 12 times, which is over the course of 6 years. So every 6 months you'll be paid. Well, when I plug that in, I'm going to get a number that's just a little bit larger. So 50 times 1 plus 0.03 divided by 2 raised to the 12th. And that gave me an extra 8 cents. Yes. So the formula says how many compounds are there per year? That would be 1. And it's 1 compound for 6 years, which gives you 6. The next one would be 2 compounds per year for 6 years for a total of 12. So that's a good question. Okay, I have built a calculator. So this little calculator has the formula built in. You can see it right there. And then we can type in anything we want for principal, years, rate, and compounds. And I want to show you what happens as we increase the number of compounds. So if we start with $2,000 for 15 years, maybe let's zoom in a little bit. So we start with $2,000, we leave it in the bank for 15 years at 5%, and we compound once. Okay? Well, if I put a 2 there, I can... It's once per year, yeah. Oh, I need to... Sorry. So if I'm going to make this work, I need to do... I need an absolute here. I need an absolute here. And one here. Okay. Now it'll let me drag it down. So if I have 2 compounds per year, I end up with 40, what is that? $38 extra dollars. And I could type in 3 or I could type in 4, but what I want to do is compare. I want to compare this value with this value. So I'm just going to make a whole bunch of these. So you can say going from 1 to 2 we gained $38, and going from 2 to 3 we gained, what is that, $12? And going from 3 to 4 we only gained 7. So it's going down, right? So eventually, now that went up to 40 cents, 43 cents. That went up not very much. Let's go down. So the difference between 66 and 67 is 2 cents, right? So, whoa, I don't know what just happened there. Okay, so let's compare. Let's say we did it every week, 52. And then we did every day, 365. And then we did twice a day, which would be 730. And then what if we did it 10,000 times a year? What do you notice? That it kind of it slows down to the point where it kind of quits growing. The difference between once a day and 10,000 times a year is only 21 cents. Okay, let's say 5 million times. What is that going to give me? Not even a penny. 7/10 of a penny. Okay, let's. That one did like 30 cents. Uh, something, something's wrong here. Let's. Wow. That's really interesting. I don't know why that happened. So you can see that eventually compounding more often doesn't help that much, right? The difference between once a week and once a day is only, it's just over $1, like $1.30. Okay, and the difference between once a day and 5 million times is like $1. So you can see that there's an upper limit, right? No matter what numbers we put in, are we ever going to get $5,000? No. What does it look like we're approaching? It looks like 4,234 is as high as we're going to get. Would you guys agree with that? We can't get any higher than 4,234. Okay, so there's an upper limit for that. Well, what if we compounded every instant of every second for the entire year? How many compounds would that be? Infinity. And we would end up with this formula. We would end up with present value times 1 plus 0.03 divided by infinity raised to the infinity times time. Now that's a bit of a problem, because what is anything divided by infinity? 0. So we basically have 1 plus 0 raised to the infinity. And that kind of breaks apart. We don't know how to solve that in its current state, but we figured out a way using calculus to know exactly what that's going to be. And it turns out that this formula simplifies down into P times E to the RT, where this is today, and this is the rate, and this is time, and this is the exponential number, which is about 2.71. And it goes on forever just like pi. And that's where E comes from. So in that case, your bank would pay you interest every instant for every second. They would pay you interest an infinite number of times. Well, you would think that if they pay interest an infinite number of times, then your balance would be infinity, right? But how big are the payments? They are they are infinitesimal, which means they're so close to zero we can't distinguish them from zero. So according to the equation, it's saying we are going to pay you an unbelievably small amount of interest an infinite number of times, and that will be compounding continuously. Now, can a bank actually do that? Well, they could use the formula, and then at the end of the day, they could type it in. But what does use the formula? Anything in the real, in the anything on Earth or space that really goes up and down, not something fake like money in a bank, but erosion of rocks. Right? The rock is always eroding. Growth of bacteria, population. Right? There are always kids being born. Now, not an infinite number of times, but it's close enough that we don't really care. And it turns out, if I were to plug 365 in here, that is not very far off of this. Right? Once you get up above 100 compounds, there's not that much difference between 100 and infinity as far as compounds go. Okay? So anything in the physical world will use the continuous compounded equation. So we actually have three equations. We have y equals b times m to the x, and that is one compound per year. And then we have this formula, which handles any number of compounds per year. And then we have this formula, which is an infinite number of compounds per year. And we call that the continuous formula. PERT. Yep, we call it PERT. Okay. Let me see. So on the continuous interest, we're not going to do that whole first page. We just don't have time. And then on the next page, you can get rid of that first paragraph. You just need to do problems 1 through 6, compounded continuously. So you'll use the PERT equation. All right? Yes. So